The end of ice. This speech requires Evan to research and present on a topic that interests him. Okay, Evan, take it away.
Many of you might be thinking, what does Evan mean when he says the end of ice? Is he going to talk to us about global warming? Is there a new product out there to keep drinks cold in the hot summer months? Is his freezer broken? The answer to all of those questions is no. ICE is an acronym for the internal combustion engine. As part of my Pathway program, I had to research and present a topic that interests me. And I've always been interested in vehicles and building gas-powered motors, but I also understand that my hobby might look a lot different in 20 to 30 years. Automakers are starting to phase out cars that are solely powered by internal combustion engines as governments and countries look to tackle fuel emissions. So electric engines are gaining in popularity and are likely going to power the automobiles of the future. So on my screen here, I have a quick shot of what an internal combustion engine is. Fuel comes in, spark ignites it, the piston goes down, it goes out the exhaust valve. So in 2020, electric vehicles or EV sales made up only approximately 2% of the total market share. It's estimated that by 2025, EV sales will make up 30% of the market share, and by 2050, EV sales will surpass 80% of the market share. So that means that in approximately 30 years, the combustion engine as we know it today will essentially be phased out. The CEO of Tesla, Elon Musk, once said, when Henry Ford made cheap, reliable cars, people said, nah, what's wrong with the horse? That was a huge bet he made, and it worked. This slide here shows in 2015 that 98% of the vehicles on the road in 2015 were pure internal combustion engine, 88% in 2015, and then it's predicting for 2025 that 68% pure internal combustion engine, and by 2030, the hybrids and electric vehicles are going to surpass the internal combustion engines. So this really gets me thinking because I'm restoring gas-powered vehicles, and in the next 30 years, parts might be hard to find or non-existent. I might have to start thinking outside the box and try and fit an electric motor into a retrofit it into a muscle car. So during my research, I read many articles related to the electric car. There seems to be three primary reasons why people still prefer the typical combustion engine. The first is people are nervous about the car starting on fire, the wires, the battery starting on fire. The second reason is the car's range before the battery dies. And the third reason was how long it took to charge the battery. So I looked into each one of these concerns in a little bit more detail. So the first concern was the car starting on fire or the wires getting too hot and starting on fire. So Tesla claims that gasoline-powered cars are 11 times more likely to catch fire as compared to a gas car. Tesla compared fires per 1 billion miles driven, and the Tesla fire rate is only 5 fires for every billion miles traveled, compared to 55 fires for every billion miles traveled in a gasoline car. So again, 11 times more likely to catch fire in a gasoline car. The second issue was how the battery range, sorry, my slide jumped. So the average electric vehicle range is only 200 to 250 kilometers in 2020, which is considerably lower than many of the comparable combustion engines. Many manufacturers do offer the longer range batteries, and you can get up to 600 kilometers, but it comes at additional costs. So experts are anticipating that the average electrical vehicle range will increase to 800 kilometers by the year 2025 as the technology keeps improving. So that slide, there you go. So the third reason was how long it takes a vehicle to charge. A typical electric car takes 8 hours to charge on a typical domestic outlet from empty to full. The charging time really depends on the battery and the speed of the charging point. So typical domestic infrastructure, such as your house outlet, can only charge so fast. So companies like Tesla are installing the rapid charging stations throughout North America, similar to the one that you see in Fort Macleod. The charging station typically allows a battery to charge up to 80% in just 30 minutes. So as EVs become more popular, it's anticipated that the rapid charge stations will be installed throughout the country. One final point that I found interesting is that manufacturing a mid-sized electric car results in 15% more emissions compared to a gasoline car up front, and this is primarily due to the battery production. However, once the vehicle is complete and on the road, it's a whole different story. Electric vehicles make up for their higher manufacturing emissions within 18 months of driving, and then they continue to outperform a typical combustion engine throughout the rest of their lives. The average electrical car on the road today has the greenhouse gas equivalent to about 88 miles to the gallon, which is far better than your typical truck that gets 20 or your typical car that would get 30 miles to the gallon. The research I completed really opened my eyes to the future of automobiles. As technology advances, there will be less and less gasoline-powered cars on the road. It will be the end of ICE as we know it. Madam Toastmaster.